I knew I would forget. Okay, so we started the recording. Welcome to the lab meeting. It is September 7th, and I'll get started with a quick presentation as soon as I can figure out how we share the screens again. All right, can you guys see that okay?
Yep.
All right. Okay, so one of the things we're going to talk about today is sort of organizational, figuring out the easiest ways to kind of keep sharing data. Now that we're multi-institutional, it's going to be a little extra challenging to do that. So we'll kind of play it by ear, but one of the things that I wanted to start off with is, as we've been kind of developing the standards for presentations, I think having keywords on the front page is going to be good because it's going to make it a little bit easier to share the content of what goes on in here without it'll be searchable and just a little bit easier to sort of find what we're looking for. We started recording these sessions about, well, I don't know, we started recording them pretty early. I think I had to go to a conference one time. And so instead of kind of meeting live like this, we recorded our own and then we just shared them, and then we could kind of catch up with each other, kind of like a video blog or something like that. We started recording them because as the lab got bigger, somebody might not be able to be there that day, or might be late, or might have to leave early. And so it's a nice kind of record of what we did. And it's been surprisingly useful kind of being able to go back and sort of saying, oh, what was Sammy's thing about, processing the data this way or that way? And you can go back and you can see the slides. We always share the slides, but with the video, you can sort of, reacquaint yourself with exactly what he said. So easy way to just kind of archive what we're doing. As we sort of find ways for you guys to engage in the lab, whatever the project is, you'll kind of give just a short update, prepare a PowerPoint or whatever. It doesn't have to be elaborate. It doesn't have to be a long time. It doesn't have to be that polished, but just as kind of a way to kind of focus the conversation. So a couple of things I wanted to talk about today: lab communications. We'll talk about that a little bit more. We've done a little bit of that already. I've got some new-ish Pix40 benchmark results from the computer that I've got in the lab. I didn't actually make a slide for the anthropology GPS methods paper, so I'll just quickly say that Shalu Prasher, who's been working sort of a little bit with the lab, was on did anthropology fieldwork over the summer, and I helped her develop a method she was tracking, you guys remember, was it lemurs?
Yeah, she was tracking lemurs. She was up South Carolina, something that she went this year.
Yeah, South Carolina, that's right. So she was, so the trick was, how do you take GPS points at a distance? And so there's some sophisticated methods using like laser rangefinders and sort of, but we were a little worried that A, it was going to be a little too expensive, and B, it might be a little error prone. So if you're using that day in and day out, if she's on field work and it breaks, what do you do? Do you lose that whole day's data? And so we ended up coming up with just a nice way to kind of take a handheld GPS unit and a magnetic compass and have her estimate distances because they were never that far. So 20 yards, 30 yards, you can kind of train yourself to be reasonably accurate with that, and accurate enough that the combination of those three pieces would yield a point at a distance. And so she ended up finding that to be pretty useful and thought it might be worth sharing with the anthropology community more broadly. So we might be putting a paper together on that. So that was kind of exciting. So no details on that, but it was nice to hear from her again the other day that she's interested in doing that still. I don't think I made a slide either for the REU stuff, so I'll just save that for next time. But Lily, I know you're interested still in being on the paper for that. Yes. I've started writing the report. I'll share the link with you and Andrea after the meeting, and you can see kind of how far I've gotten with the report. The report is just kind of internal, but I'm seeing it as kind of like the core document for the publication that we're hoping to put out. So it'll have some rough edges, but it'll be a good start on the publication. And then what I really wanted to talk about today was statistical tests on rasters. So I've been working with Hannah Ebo, who's a grad student at NIU. And she did some really interesting work, and I've been helping her kind of process the data on that. So it's kind of a neat application that kind of cross-cuts a number of different geospatial issues. Okay, so communication is kind of a main thing. So a lot of this we've already covered. You guys have you just got the invitation to the Slack channel. You guys have been on for a week or so. We'll keep using that. I think that's been working pretty well. Other than sort of the slow start getting going with Zoom, I think in terms of the technology, Earl and I checked it out yesterday. It seems to be working okay today now that we got it going. So hopefully with a smoother start, this will work for us. We need to, so a lot of the old PowerPoints and videos have been archived and saved. I've been working on putting together a document that kind of discusses those. And what I'm thinking is having something like a lab wiki that it's easy to kind of keep track of things and update. I don't want anything that's going to be burdensome to maintain. So I'm shying away from maybe a formal wiki, but something where we're kind of keeping track of a lot of this great information that we're generating every week. I don't want it to just kind of get lost in time. So we need a way to keep track of that besides just sort of doing a search on the pile of data. So we'll just kind of keep that as a challenge. Let's see. We may want to have some kind of responsibility for keeping it updated. So a lot of meetings, somebody will keep track of the minutes. I don't know that we need to keep minutes, but if maybe we can have a rotating duty of sort of like aggregating and linking all of the videos, and then, you know, it's not burdensome for anybody, but everybody gets a chance to sort of keep track of it. So that might be a thing that you guys can do. You don't have to commit to it today, but that'd be an easy way to get started, sort of seeing what the lab's been up to. You'd be kind of looking through the old PowerPoints, and so it might be a good way to kind of catch up on interesting topics if you're interested. All right. How's the audio, by the way?
All right, we're getting a little squeak here and there, but
yeah, there's a couple of. I noticed a little bit of feedback here and there, but not too bad. Okay. These were the results of the Pix4D benchmarking, so we'll just get this out of the way. I think I shared this with Earl once already, but the new machine that I've got here is a 16-core, 32-thread Intel. It's got a GeForce 1080. It's not the TI, but still pretty good performance gains compared to what we have been using. So I've got a machine at home that's sort of like a previous generation of this that I've been running most of my data on. Earl's got a server that he picked up and has kind of refurbished and improved. So that's also, is that a 32 core or was that a
16 core? Yeah.
A little bit older generation processors, but lots of memory, pretty good horsepower. So when you run Pix4D is the software that processes the photos that you take with the drone and turns it into, so it generates an orthophoto, it generates a point cloud, it generates a 3D model. So basically you take this pile of images, you shove it into the program, and you let it run. And the processing is divided into 3 steps. So step 1 is kind of stitching all of the pictures together, and feature matching is what it's called. So finding the common elements of each picture and using that to kind of figure out how they go together. Step 2 is the generation of the point cloud, and then step 3 is the generation of the DTM, the DEM. Model gets generated in step 2. I think the orthophoto gets generated in step 3. Okay. So these are the first 2 steps, and then so that's often all we run. So I'm a lot more interested in the point cloud and then processing the point cloud to get what I need. If you want to kind of keep it easy, then step 3 will generate a DSM and a DTM. But I'm not the process. I mean, you'll kind of get the hang of it. There's a lot of stuff that goes wrong when you try to generate DTMs from a point cloud. And so I don't usually trust the results that come out of step 3 anyway. So I prefer to just process that on my own. So these are the results. Essentially, step 1 completes in about 70% of the time compared to the other 2 systems that we were using, and step 2 completes in about 60% of the time. Step 1 uses a lot of GPU processing, so that's where it helps to have a nice graphics card in there. Step 1 is the GPU. Step 2 is more CPU based.
Yeah.
Right.
Yeah.
Okay. All right. So nice to kind of share those results. I wanted to talk a little bit about this raster processing that I'm doing with Hannah. So Hannah is a master's student at NIU. She's finishing up over the next month or so. I think her defense is in October. If you guys get a chance to go on the NIU side, I think you would find it really interesting. So put that on the calendar if you see it come by.
We just got emails about that.
Okay, great. Yeah, it's really interesting research. I won't talk about sort of the content of it is pretty cool, but I want to talk a little bit about the methodology. That's where I've been mostly plugged into Hannah's work, is sort of helping her sift through the data that she's gotten. The gist of the project is to, she's got connections to the Caribbean, and I can't remember what her connections are, but for some reason she selected the island of Dominica, which has a lot of volcanic activity. And she was interested in ideas about risk communication and risk perception. So how did the people on the island think of the danger? Like, what parts of the island are more dangerous than others? Experts have evaluated that and have tried to communicate that risk to the public, but that hasn't always been it hasn't always made as much of a difference as people would hope. And this is kind of a common problem with a lot of risk communication. So meteorology is kind of the best example. If there's a tornado or a hurricane or some severe weather event, you got to communicate that to people, but they don't always interface with that the way you want. So this was sort of some basic research, sort of getting a handle on what's the risk perception on the island. It was a pretty cool methodology. So we'll kind of skip past some of this and I'll show you. This is the island of Dominica. This is a map that Hannah prepared, highlighting some of the dangerous spots. So the southern part of the island is a little bit more dangerous than the northern part, although the northern tip is a little bit dangerous. And she could probably explain better about why. The methodology was pretty cool, and I was glad to be a part of the development of that. So she had these outline maps printed, all on sort of a common framework, and then had users essentially sketch in with colored pencil what parts were more dangerous than others. And so then she would scan these documents in, digitize the contours essentially of what was more dangerous, rasterize those. So that's what you're seeing over there on the right is the rasterized version of those sketch maps. And then the cool idea is sort of taking these, so she had, I forget how many participants, 160 or something like that. A lot of people from all over the island did this. And she did focus groups and talked to people, and there's a lot more to what she did than just this. But so if each individual supplies a individual risk perception of what the island is, and it looks like each of these 5 over here is a single individual, you could imagine sort of overlaying those one on top of another. And if they were semi-transparent, you'd see like the darker ones show up as more dangerous, right? So you can aggregate these things, and it ends up looking something like this. So what I was trying to do is to put together something that like a framework that was going to be extensible. This would be a pesky project to do in ARC. Not so bad to do once, but annoying to split among all of these dimensions. So male, female, younger, middle, older, this part of the island versus that part of the island. So all of these sort of ways in which you want to slice through the data would be difficult to do in a platform like ARC. So I encouraged her early on to start doing this in some of the open source tools that are available in Python. She does not really know Python. She's been kind of bootstrapping and kind of learning, teaching herself as she goes. And so I've been trying to provide functions and methods that she can kind of access easily to sort of do that work that she wants to do, but then maybe useful for the lab later on for any other comparisons. And so I'd written some Python notebooks for her to kind of work off of. And then when we got to this, we got to a part where essentially her advisors, Walker and Courtney, were trying to say, well, we need to talk about how you assess the statistics on these things, because at one point, this is just a visualization. So this is what an aggregate would look like for all of the participants. And so it's pretty cool. So you can kind of see that the southern part of the island comes in stronger than the rest. There's a perception that the northern part of the island is a little bit, more dangerous. And so you do see that even with all of the differences here with individuals, if you aggregate those end up looking similar to what the experts had said. So this was an example of slicing through the data in one way. So this is the male versus female aggregates. There's some interesting data noise that I've noticed going on in the top. You can kind of see these at the very top of the island. There's a significant little red piece here that I'm not sure what's caused by, and there's a stray pixel there. So that's interesting. I'm not exactly sure. That's noise, though, right? Those aren't real values. Those are something creeping into the data that shouldn't be there. But good to know. We've talked in Cole and Jill are in my geovisualization class, and I've been kind of talking about outliers. This is bad data that you should definitely be aware of when you're crafting visualizations or doing analysis. This is important to take note of. Okay, so the question is, and this is a comparison of what the expert one looks like compared to the aggregate for all participants. We can do some really simple things like essentially like raster algebra. So you can take the average male response and the average female response, and you can subtract one from another. And what that tells you is where are the differences, right? So this is the male raster, this is the female raster. Where do men find the island more dangerous than women, or vice versa? So in this case, we've got a visible difference in the north, right? We see some differences down here. But the next good question is to say which of these are statistically significant. So just because we find a difference doesn't necessarily mean that that's real, right? That could have just happened because of the people we happen to talk to. And so we have to use statistics to sort of say, well, let's dig into that and let's see how robust we think these results are. Essentially, the way we would do this in statistics is to use a t-test. So we would compare population A, or sample A, sample B, and we would run a t-test to see if there are any differences. We'd be looking for things like, does the p-value less than 0.05, but we'd also be looking for things like, what is the effect size? So the effect size is essentially a standard measure of the differences in mean divided by the standard deviation. So if you guys know what z-scores are, it's essentially like a z-score for differences in mean. So there's some sort of standard interpretations about what's a strong effect, what's a medium effect. So Cohen, the measurement that we're using is Cohen's D, which is a measure of effect size. There are other measures of effect size that are useful. But Cohen's D is going to say, well, a 0.2 is kind of a low effect, a 0.5 is moderate, 0.8 is strong. And Hannah found a great video kind of going over that. So I'm not going to link that. We're not going to watch that or anything, but if you're interested in digging into effect sizes more, that was a really nice summary. We may also want to do things like normalizing. So there's a section in here that I added to normalize, and I'll talk about that in just a second. But lines 240 and 241 are a normalization of, in this case, a male and a female raster. This is the way that so one of the nice things about, just below the arrow here, one of the nice things about running this analysis in NumPy and Python is that you can run a t-test on rasters, stacked rasters. So these are three-dimensional rasters. There's rows and columns, but each individual is a on the z-axis, right? So the z-axis is different people, and you can basically run a t-test. So you're pulling in the SciPy stats library. You're running an independent t-test. You're passing it those different stacks A and B, and then all you have to do is say axis equals 0, which means I want you to calculate these, squash it on kind of the vertical dimension, and run it that way. So it's a single line of code to run t-tests on a three-dimensional raster, which is great. So that's the beauty, I think, of working in NumPy versus if you had to do this in Arc, it would be a nightmare code. It would suck. So that's cool. So a lot of the basic stuff you can do with just a single line of code, like you see in line 243. And I put a copy of all of this code. These are just screenshot pastes into the PowerPoint, but all of this code is in the lab report directory. So if you want to dig into it later, it's there. For some of the oddball tests, so for ANOVAs and for non-parametric tests, I had to write something that would just loop over it and run it by each pixel. So for Mann-Whitney U, for an ANOVA, a one-way ANOVA for the Kruskal-Wallis test, you're essentially just looping over each row and column and doing it that way. But it runs pretty fast. It's just really basic arithmetic, and so it doesn't take long to run this code, even though it's kind of inefficient. A nice thing to do would be to extend these in the real SciPy routine. I don't really expect anyone here to do this, but last Christmas I was running into something where, you know, there was something that could have been done using SciPy, and I could write the code like this to make it work. But instead of doing that, I actually updated SciPy, so contributed to that, which was a good experience, being able to kind of, you know, work on a common code instead of just sort of solving my own problem. I could solve the problem for everybody. So it would be pretty cool to do this for all of these tests so that it could run just like the independent t-test, just say axis equals 0, and it would handle all of that looping internally. So this is an idea of what it would look like, or what the results look like anyway. So we have the male and female rasters on the left. The middle one is just the difference, so A minus B. What you're seeing over here on the right-hand side is a masked effect. So it's masking anything where the p-value is greater than 0.05. So anything we think probably could have just happened due to chance, we're squashing. And then anything where the effect size is under 0.2, we're also suppressing. And so all you're seeing are sort of the statistically significant, interesting differences. And so you can see that there are some interesting differences in kind of all throughout the island, and then just a little bit in the north. One of the things that she's run into is that A and B, so the male raster and the female raster, you could run into a case where men or women just amplify the differences, right? So if I asked you to rate all of the Star Wars movies or something like that, and you give them 4 through 6, and I give them 7 through 9, like we could still compare the individual differences, right? Like I thought this movie was better than that movie, but we'd have to normalize them. So this is kind of the unnormalized, where what you're seeing are sort of absolute differences. And this bottom one is where we normalize them, we align them, so now we can sort of compare just the relative differences rather than the absolute differences. So that was kind of nice. And so all of the code that's there, one of the comparisons that she's interested in is, do participants see things differently than experts? And so now she can run some simple code to do that. And I've got a meeting with her this afternoon to kind of go over this, stuff. Okay, that's kind of the last of the meat. I'm going to talk about the goals, but did you guys have any questions about any of that?
No, we're actually looking at your Python code on the other screen right now. So.
All right. Did it? So I had uploaded it to Dropbox just before we met. Did it propagate over then, I guess?
Yep.
Very good. Okay, so we started doing these research goals, I don't know, within the last couple of months, I think, of when we started doing these. And we found it a helpful way of both looking back on what our goals were in the previous week and then what our goals are for the next week to try to set discrete things to really kind of move ahead on. So this last week, I was really oriented around solving this problem for Hannah because she's hoping to defend in October. So I wanted to get this code written so that she could do it. Sammy, I feel awful because you've been asking me to do the water stuff for a while now, and I haven't.
I feel bad too because I never sent it to you.
Well, feel free to send it to me, and we'll figure it out. That reminds me, in terms of trading files, Dropbox will work. Google Drive will work. I don't know. I think we're just going to have to muddle through it until we figure a good framework out. But I think Dropbox is going to be good for the, at least for the lab reports. So I know that I shared something on Google Drive, but I think Earl, if you're down with it, because you've got a good Dropbox account.
Yeah, that's fine.
You and I can be kind of the focal points for Dropbox, and then all of the links to everything can be shared with everybody without having to share, the files themselves, which would require like a bigger subscription. So, All right, so next week, some things I want to do is to get the stuff, all of the stuff I've done for HANA has so far been kind of a one-off, but I think I might as well fold that into NeilPy. So I started NeilPy about a year ago as a way to kind of code that we think is going to be likely to be used in the lab again. We'll fold it into a Python package that you can install with pip and download. And so that's on GitHub right now. So if you guys want to check out NeilPy, you can download it, you can install it. Easiest way to download it and install it right now is to literally just download the GitHub thing and then run pip. We should get that distributed via PyPy at some point so that you can literally just say pip install NeilPy and it would go, but we don't have it there yet. So you can install it with pip. You just have to download it first. So I got to get that stuff folded in there. I just got my Iris, so my old 3DR drone that's been kind of the workhorse for me. Earl's got a nicer, newer drone, and Sammy's got a nice new fixed wing that he built. But I'm using very old 2.5-year-old technology. But anyway, I just got to put back together and it's flying. I also ordered the parts to build. This was just last night, actually, to build my own Busy Bee. So I'll have my own, and then I ordered all of the parts to build a Busy Bee. So this is the lab drone that I designed and put together. It's all 3D printed. So we'll have one for the lab. I'll have my own, and hopefully those will be online in the next couple of weeks. On that front, Virginia Tech has a very elaborate drone policy. So I'll link to this.
Whoa.
There's a whole nice, shiny, glossy pamphlet, and they've got a drone park that you can go into and fly. But the rule is actually you have to have a Part 107 to fly on campus outside of the drone lab. So you cannot fly recreationally on campus.
It's new.
So yeah, strict, but probably good because I think we'll tell you some stories down the road of some of our nobody ever got hurt, but we had one particularly awesome crash that on a Friday afternoon that was not a lot of fun. All right, and then to make some good, my last goal for next week is to make some good progress on the R-Review report. The longer that goes on, the less likely that is to get published. So I got to keep with it and get that out. Okay. All right, that's me. So, Sammy, how long do you have? I think Earl and Lily, do you have to take off?
Yeah, I'm 9 minutes.
9 minutes? Did you have something to present?
I have time. I'm actually not presenting today.
Okay.
All right, well, I guess I'm up.
Well, Lily, are you presenting?
No.
No, okay, just hanging out. Great, okay, Earl, then yeah, go ahead and hit it.
All right. Mouse. Fine. Mouse. Okay.
Are you taking off, Lily?
No, I'll be right back.
Oh, I think I'm still sharing my screen, right? That's probably what's
Yeah.
Oh, here it is.
Uh-oh.
There we go.
Oh, there it is. Just thought I lost it. I'd moved it into the Dropbox folder instead of copying it.
Ah.
Okay, we're good. Hold on. Here we go. That's yours.
So we used to try to say that these things should be 15 minutes long, and then what we found out is that I always go long and Earl always goes long, and so.
Hey, I tried to make it short because I knew we had a lot of people this week. So, and we don't have a clock on this. I don't know. Do you see a clock on your recording side?
No.
Yeah. See, normally that's what we have to watch the clock, or else we will go on forever.
So they're supposed to be short. I just, once you get into professor mode, you kind of just talking.
Okay, now let's see if I can share my screen. Hold on.
Okay. Yeah, no worries, no worries.
Wait. Where'd it go? Hold on.
Hey, my bike is still there.
That's your bike? I'm trying to figure out whose bike it is. No one's No one knows whose bike it is. Now I know.
Yeah, you can. My plan was to just like put it in one of the bike parking spots and let somebody just steal it. But then I thought it might make a handy lab bike. So yeah, feel free to do whatever you want with it. Give it away. I thought maybe like a starving grad student might want it.
Oh, we're all
I
that.
mean, I'll take it if you don't want it.
Yeah, you can have it.
Oh, thanks.
It's not a great bike, but it's okay.
Yeah, that's all I need. Something with wheels. So.
Okay. Let's see. Are you guys seeing my screen by any chance?
See some space
I can see
telescopes.
Oh, yeah. Okay. So let's see. Are you seeing it?
Yep.
Okay. So let's move that over here. Okay. This is my lab report. I guess did I say the 6th or is it the 7th? For September 6, 2018. Keywords for the day are processing, proposal, puzzle, I'll get to that, and 3D printer. Yay! To start off with,
Actually,
Okay.
I'll just go now, so I won't interrupt in the middle. So you can tell me about everything later, and
Okay.
I'll watch it. So
oh, sorry.
anyway, it was nice.
It's good to see you too, Lily.
See ya.
Stated on the next meeting, so hopefully I can get some stuff together and actually present next time. Yeah.
Okay. All right. Sounds good. See ya.
Class.
See ya.
Okay, I had set my goals for the last week. First thing was finishing flights. Second was to finish processing. Third, which is the one that's been driving me wonkers, is the working on my proposal. For you undergrads. Ah! And then we had the start of classes since our last meeting. So to go on with that, I'm getting a little bit of lag here. For my flights, I for the new members, my thesis, I'm actually working on UAV-based height estimations for the urban tree canopy in the town of DeKalb, where we're at here. One of Dr. Pringle's previous grad students went out and hand measured over 1,000 trees in the area. And so now we're trying to find a way to basically expedite that situation using UAV. So what I've been doing is I've been flying my drone around the city and building point clouds from that data. These are the two sections that we are looking at. The section in the red is a older, more well-established area of town. Call it the historic districts, historic north and south. The section in the blue is actually newer construction, so 10 to 15 years maybe at most. And those have newer trees, which tend to be smaller, more spindly, less well-defined. The older trees are generally large, well-established trees, large canopies, and not as homogeneous. There's a lot of mixing of trees because, you know, over time people plant different things. So I took a original data set in the spring when the leaves were off, getting most of this section. It worked out somewhat well. You can look at some of my older ones, or you'll actually see that as I go along and present in different weeks. This new set I was trying to get in was called my Leaf On set. I finished that up in the last week. So maybe there's a few points I might want to go to fill in, but I took a total of 35 flights for this new section. It's actually more than I took for the previous section, but I was able to tweak and isolate things that really needed coverage and change the shape and size. The original flights were all just large block chunk sections. This one I sort of targeted where I wanted to fly and made a little bit more efficient use of the coverage that I was able to get. The first section, which is, oh, can you see the mouse there or no?
Yeah, we can see it.
Okay, oh, cool. The first section is this Knoll section here. This is a newer subdivision. This one was pretty much a very straightforward 10 block sections of it. The second section is this area over here called Kensington Point. It's a very small section, but it's probably the newest of the sections, I believe. well, the null section, this is pretty established here. It's been there for a while. This section here is still building. So this is the old section, that 10 in this section, 4 in this section. The other areas, the historic sections, the historic south is this section here. It took me 7 flights to cover that. And then finally is the historic north, which is this section here, which actually took 14 flights. And a lot of that was just due to weatherage and technical issues. A lot of flights I was only able to get half a flight in before either the winds were too strong, draining my battery, or loss of data. So I actually had to refly several of the flights multiple times. In total for this data set, I have 11,290 images that I'm using to process. Those, let's go on. Okay, come on, move, next, no, yes. These are the logs of my different flights. And as you can see, we're working on the naming structure, which is one of the things that I've come to truly appreciate working with Dr. Pingle, especially with these flights, is keeping track of them has been quite a fandango. So this is my log. There are about 10 more cells in the log, but these are just the important ones. The flight name, well, the flight number, whether it was on or off. I only included the new flights in here. The section, vehicle, date. These characteristics here, as you get into flying, I know Sammy knows this. This is the overlap. Well, the elevation is the first one. How high above the ground I was flying. The angle, the oblique angle. My cameras were not actually pointed directly down. They're pointed slightly off center. That's through some of my background research on my lit review, I found out that that has been found to be the most efficient way to do it. And then the overlap, how much of each image is covered by the other image to stitch together. The same article, well, main article that I'm working with on that said 80% is the optimal choice. So those are just some of the categories here. There's a lot more data, but I won't bore you with that today.
What's the last column?
Last column is the images for each flight.
Okay, cool.
So
the table that should go in your appendix.
Yeah, I've got this. I've got a nice big long section with all the other data. I also have the flight mission time. I'll talk about that here. It's in my thing for you for the next week. But the flight time I found I'm using the Pix4D built-in flight programming software, and it'll give you a estimated time of flight. But of course, it cannot consider the environmental variables, how much wind is out there, and it does not calculate your time of flight to take off, time of flight landing, or your flight time to start and finish. So what it says your flight time should be is never really what the flight time is going to be. That's actually in my, I'll talk about that later. Well, won't talk about this time, but should be for the next report.
Okay.
Okay, so that's just information on the flights. For processing, this is what my original leaf off processing came out to be. As you can see, there are some gaps in data. That is a data set that is just completely lost. Somehow my card got unformatted, and so I lost that section. There were some other ones missing that I've been able to recover and reacquire from some people. So these are 3 sections. Well, basically they work out to be 3 sections. The null section, the Kensington, and the south section for later processing will just be considered one section, one data section. And then the northern historic district section will be here. In one of my
missing block. How likely do you think it's going to be that you can refly that in November or something?
Yeah, I plan to do that.
I mean, can you anticipate any issues with it going, like, merging it? Like, I don't know.
No. I think now that one issue I was having was getting my point clouds to mash up. I talked about this in previous meetings, but for the newer people, the software tries to establish a base ground level for all this data that you're putting together. When it comes and it stitches all the images together, it tries to say, well, I'm at this height, and the focal length, I think the ground is this distance below me. One of the problems I've had with the unit itself is the flight heights are not meshing, and I've been digging into this, Dr. Pringle, and I still cannot figure out why this is happening. We think it may have something to do with the geoid, but it's trying to give me the ground elevation for my flight elevations. So we were getting stacks of data points. So what I did to solve that was I manually readjusted, thanks for some of the information I found from Sammy's reports before, that you can manually adjust what you say your flight height is for the images. And so I take my launch point, find that through the LiDAR data that we have of the area. I find the point, literally the point that I launched on, and then I add my designated flight height, which is 80 meters above the ground, and I set that as my overall flight parameters for that entire group. So then when it processes down, it has started coming out very well. They are lining up so beautifully, so much more beautifully than I was having before.
That's great.
So I think it should be no problem meshing those right back in.
Okay, cool.
Talking about processing, I have been going through the different methods, and I have gone back to stacking, processing the subgroups, adding those together, and I'm trying to add them together along seams. So I don't want to add something that has 3 seams at a time. If I only add something that has a single seam at a time, it tends to process a lot faster.
Oh, okay.
I'm talking substantial. Like if you had to do 2 seams or some, if I added this section into this portion here, it would probably take about twice as long. I have not done the actual numbers. I have all my reports so I can look those up, but
Okay.
I would say it's at least twice, 3 times as long. It's just trying to do so many different new calculations on it.
Sure.
So I'm getting off the topic here, and I missed the end. Okay, so that's my old data. Now the new data, these are the 2 sections. The nulls, that's what actually was still processing when we started. It was making all that noise, so I stopped that. But we've gotten really good complete coverage. I've tightened up. There's a lot of excess information here that is not part of the survey zone. So I've been able to tighten up my flights and just really get what I need. And it has come out, oops, ooh, now you're working, aren't you? Okay, so it's coming out very well. There isn't error in the nulls, we're rerunning. And they are tending to mesh very, very well. Maybe only a meter or 2 of readjustment now when I actually stack the 2 layers. So it's coming in very well. As an example, I will show this next one. There we go. The white is basically the LiDAR layer, and the colored is the new point clouds. And so the only difference you're seeing, these are laid on top of each other. This is pre-processing. Don't have the final processing ones done yet, but the only thing you're seeing in here colored are the discrepancies. And most of these are actually tree points and vegetation growth. So this is the leaf off condition, and this is a leaf on condition, which is pretty much all vegetation that we're seeing difference. And this is just the rough stacks. So it's actually coming out very well. I think it's gonna work out really well in the long run. Okay, so that's where the processing is at. Next, I've been working on the proposal. I've been working on incorporating the edits and the suggestions that you had given me on my 1 page for my introduction section.
Okay.
My lit review, that's been going very roughly. That's the part I expected to have the most trouble on, and I'm trudging through it, but it is getting rough, and I'll talk to you about that later.
Okay.
The methods and materials and methods, I think I'm pretty much done with that. I want to do some touch-ups on that over the weekend, but
Okay.
that went fairly smoothly. And my conclusion, I'm really just trying to figure out what I'm saying in that section. And I do have some questions I'll talk to you later about how to structure the proposal conclusion as opposed to a report conclusion.
So when I gave you a copy of
And Charleuse.
I give you a copy of yeah, okay. Sammy, you probably did a proposal, right?
Yeah, mine was pretty short though. It was just like a 2-page proposal.
Okay. Yeah, I don't know. I think probably don't, Earl, when it comes to your proposal, I would say don't overdo it. So some people, when they write proposals, the idea is to have the lit review done. But I think if that's a sticking point, like, let's not get stuck on it. Let's just, because you need to know enough to do the work that you're doing. You don't necessarily need to have every last thing covered. So,
Yes, it's my writing style. I have the stuff I know I need to say.
yeah.
Just trying to figure out how to say it was what's.
And you've got the table that you wrote, right? Like, that table looked pretty good the last time. So yeah, we can talk about that individually, but yeah, I'm glad to hear that it's coming along. Did you want to talk this afternoon?
Well, we are in class until after colloquium, because I have. I'll talk about classes in a second too.
All right.
So, I'll talk to you later about actually trying to set up a personal time. So that's how the proposal's going. It was rough getting started, but I think actually I'm starting to move along, and hopefully I'll have a draft for you to look at compiled. I want to, maybe by the end of the week. I want to have like maybe my methods and my intro and methods in a folder for you to maybe look at Monday, and that'll give me some time to get the rest of that together, so I can try and get everybody a time when everybody can view the proposal, hopefully within the next 2 weeks.
Okay. Yeah, let's try to, if you've got the time, let's try to meet individually over the weekend. Just a quick Skype or whatever, and then just send me whatever you have, like, Sunday night.
Okay.
Don't worry about polishing it up. Just whatever you've got, and then we'll go with that.
Sounds good to me. Okay, next. So classes. As a student, I'm taking the Advanced Spatial Analysis, which is, I swear I'd never take another analysis or statistics class, but I needed to get my another one of my advanced courses in, and I think it's actually going to be an interesting class. That's with Dr. Chen. So
okay,
it's not turning out to be as bad as I thought it was going to be, so it's actually looking really interesting. And then I'm taking Geography of Health and Disease with Dr. Wilson, and there's only 3 of us in the class, and it seems like only 2 people are actually paying attention to the class. So it looks like it's going to be more of a group effort. And my familiarity with remote sensing techniques has really got Dr. Wilson very, very interested.
Good.
I've already turned him on to planet.com, and we spent half of one of our classes just pulling up imagery to overlay.
Ah, cool.
So that's going very well.
Have you guys seen planet.com? Oh, I should probably talk about that in Juvid's class at some point. It's a way that you can, their shtick is that they image the whole Earth at a good resolution, often a meter, right?
Yeah. As a student, we get 3 meter for free, but they resolve up to a meter. Yeah.
But the really cool thing is that they do it often. So you were saying like every day, yeah, and then you can pull it down practically in real time. So that's amazing. That's the cool part, I think, is that you can pull really, really recent stuff, and you could look at stuff every day. So lots of really neat stuff. Okay, sorry, go ahead. Yeah. Okay.
As my
Good call. All right.
Thank you.
Yeah, thanks for coming.
All right.
Thanks. Bye. Austin, right?
Hudson, nice to meet you guys.
Yep. Nice to meet you too.
Nice to meet you guys.
All right, see ya. We'll post the video on the Slack channel.
Okay, thank you.
Okay, for TAing, remote sensing, it's actually a full class. I've got 18 people in the lab. So all the computers are full, which is kind of cool. And
Yeah, and I'm in that class too.
Oh,
and
yeah?
he's the only grad student this year, though. This year he's the only grad student in the class. So
Weird.
yeah, so it's kind of cool. Seeing a lot of undergrads wanting to take that class is really kind of cool. And then for my intro to environmental geography classes, 2 decent-sized classes. I got a 9-person and a 10-person class.
Okay.
And so that's going good. Now, what else? There's 1 or 2 more things to. 3D printer. that thing is being a little bit persnickety. I've gone through and recalibrated it, and it'll run fine after it's recalibrated. But if it sits for a day, you have to recalibrate it again, or it will start gouging. So I'm not quite sure what's going on with that.
Yeah. That might be worth an email to somebody. Have you been digging around on the forums?
Yeah, and I downloaded a new version of the installer, so that's going to go on today. So I'm going to reinstall the initial software.
Yeah.
They did say last update was at the beginning of this year, and there was an update that dealt with some of the leveling issues, I think, last year that I don't think we've put in yet. So
Okay.
maybe those will do something. If not, we'll see.
Can you I mean, this is a super oddball one, but I really feel like the USB ports on that computer are off. Which computer are you running it on?
Just the printer computer.
Yeah, can you try like using a different computer for it and just see what happens? The laptop, the old MSI GT60 could be around. Just see. Something weird was happening with those USB ports, and I wonder if that's contributing.
Okay. That's a good to think about. So I have been able to get some things printed on it, though. That is a good thing. But I've been watching like a hawk. I've literally, whenever I'm printing, I pull up the camera view and I watch it.
Nice.
While things are printing wherever I'm at, so I can see what's going on at all times. I'm a little paranoid right now. Then, if you can see there, you might be familiar. Those are some of the DeKalb watershed pieces that are being printed out. Because for a de-stressor, I decided to solve Lily's puzzle problem. Because I needed something less stressful than everything else, I decided to solve her puzzle problem.
Okay.
I seem to have a working solution.
All right. Let's hear it.
And as you see, these are all pieces I've printed up that actually fit really well together, nicely tiled, and they can actually snap into each other now. What I did was I went in and actually created a buffer zone along all of the shape edges. And then I took the buffer zone and I assigned that to black.
Okay.
So when you go to print out the segments, you overlay the buffer zone on the segments, and it takes that little bit of edge, and the edges will match now because the buffer zone is on both sides of the border. So when you print it out to a PNG, when it prints, that maps to 0. So it's giving you a nice little edge along all the shapes that seem to line up and match up very well.
How do you decide how big of a buffer to put on there?
That's why I'm still tweaking that piece, but I'm doing it in feet, meters, like 25 meters on each side of the line, or 50 meters on each side of the line.
Okay.
So it's enough that it's cutting a little strip out, but it shouldn't change the overall. And I think as we work up, these are just small pieces. You can just doing the little small pieces to test it out.
Uh-huh.
Yeah.
So let me catch Jill up on this one. And Sammy, I don't know if you've seen this one either. Lily was working for, where was she working again?
DeKalb Conservation, or something with the DeKalb
Yeah, conservation something. That's right.
Yeah,
Anyway, they're really interested in the watersheds, and so we wanted to print the watersheds out as physical models. That part went fine, but one of the things we noticed is that the puzzle pieces, like they mostly fit together. So these are like the individual little watersheds, and we made them bigger, but these are just little test pieces to play around with. But if you think about like how a puzzle is made, like there's some stuff that gets subtracted so that it can actually fit together, because if it were perfectly cut, I guess it would go together. But if it's not perfect, then it doesn't quite mesh up. Does that sort of make sense? So we're trying to figure out how to make them fit together like puzzle pieces a little bit better. So yeah, it's a cool idea.
Yeah, it seems to be working well. I think when we bump it up to full size, there's just enough of a gap that they should lock in very well. It's enough to offset the elephant foot at the bottom,
Okay.
but it's not enough to really distort much of the actual shape.
The elephant foot is the very bottom level, so it deposits like this melted plastic. And the very bottom level often sometimes like spreads out a little bit and like compacts. And so you get this, if you make a hole that's supposed to be 4 millimeters, it's often a little bit smaller than that because it kind of oozes in a little bit.
Right. So that was my stress release working on this over the week.
That's fun.
It seems to have gone out fairly well. Other than that,
Demo for STEMFest if you can get it finished.
oh yeah, that's coming up, isn't it?
Yeah.
Okay, I think we can do that. I'll talk to Lily about that. Yeah, she hadn't even seen these until today when she walked in, so.
Good. Tell Dr. Shagnon about it.
All right, I will.
Might if we need to buy a new print bed, that might be a good reason to do it.
Hey! I like the way you're thinking. All right, so next, so this is basically what it looks like if you printed the whole thing up. It's just the small little buffer line. It's enough that it sort of smooths some of the zigs and zags, but it fits both sides. So it seems to be working. I'm really kind of pleased with it. It was something that went well this week. You need those little positives today.
Yeah, you do.
So, okay, that's it for it. So on my goals, I got the fights finished. Processing's pretty much finished. I'll just have to rerun the one I killed today to make it be quiet. Work on the proposals, halfway there. Intros, doing really well. Lit review, not so well. Methods and materials, really good. Conclusion, still working on that. Classes started. So for this week coming up, pretty much I'm just trying to keep up with classwork and work on my proposal. Those are my big things of the week. I'm trying to keep it simple just so I can just have something to do.
Okay.
And so that is it for me.
Excellent. Thanks, Earl.
All right, let's and stop share. There we go.
There we go. All right, everybody's back. Sammy, how are things going? Just informally?
They're going pretty good. I've mainly just kind of like settling into classes lately, so I haven't done a lot of drone related stuff. I have a lot of water quality data that I need to put into different kinds of charts and tables. So I'll probably be working on that. And I'm thinking about how I want to present the DEMs that I have, because I've been using the QGIS like color gradient, which it works, but I've seen some other like presentations of like really fine resolution drone DEMs where they have I guess some kind of like hill shade, shadow that looks better. So I was thinking about like going on ARC and trying to find a nicer way to present the maps that I have.
Okay. Yeah, let me know if you've got any questions on that. So there's a lot of good resources for terrain representation. Are you taking, which GIS classes have you taken so far?
Right now I'm taking fundamentals of GIS, and I took a like half semester introductory GIS class in undergrad.
Okay. I've got a lot of the old videos from the GIS class that I taught on terrain representation. So you could probably just peek ahead and see how that stuff's done.
Okay.
Send me an email and I'll send you the links.
Okay. Yeah, I'll do that.
And on that, feel free to come down and bug me, Sammy.
Okay.
I'm always here to help too.
All right. Thank you.
Okay. All right. Well, thanks everybody for taking the time. I think it worked pretty well once we got going.
Oh, I figured out what the problem was, why it wasn't working. I was trying to use the web-based Zoom, so my system was not allowing access to the microphone.
Got it.
So I had to switch to the downloaded program.
Okay. Yeah. Mystery
People
solved.
saying no, we don't want you recording. So.
All right. Well, thanks everybody, and Earl, we'll talk to you this weekend.
Yep, sure will. All right.
All right. Bye.
Bye.
Right, Jill?
All right. So we need to stop the meeting.
Bye.